for showing up so early in the morning of the last day. Let's jump right in. In 2015, City of Cambridge ran two open innovation challenges to find a way to improve the city. Basically, it told the city residents that it had more than $1 million and it wanted to find a way to coming up with a way to make the city better. So people can go to the online platform that they have opened up and submit their ideas, and they receive 40 ideas, and in the end, it led to 43 different projects, ranging from having free public Wi-Fi to have some outdoor exercise equipment. And this is one example of gathering an idea from a lot of people to solve problems that people care, that the community care about. And it's not the only, and this is not the only domain. We can see similar platform that used to solve social problems or coming up with ideas for products or services. And the things that these platforms have in common is they all want to leverage the power of the crowd to generate the ideas that are both creative and diverse. However, with this new potential, because we get a lot of ideas, it also introduced a new challenge, which is because we have so many ideas, sometimes it's hard to make sense of what is going on and trying to find inspiration in that. Let me give you a concrete example. Imagine that my friend and I, we are Lego minifigure collectors, and we want to come up with new ideas for new Lego minifigures. And we say, okay, maybe we can take inspiration from existing minifigures. And we go look up on the website, and they are like, whoa, there are like hundreds of these available. This is so overwhelming. You might have some question that, oh, how do I find inspiration from this thing? Where do I start? And what is going on over here? In our project, we designed a system that helps solve this problem. The system is called IdeaHouse. It's a system that people can help people generate ideas in group. And one special thing about IdeaHouse is that it helps users explore ideas and find interesting ideas by using information about the ideas that collected from user natural activities while they are generating ideas themselves. So let me give you an example. Going back to the Lego minifigures example, here in the beginning, maybe, I don't know, like I got stuck, I don't know how to come up with new ideas, maybe a set of, I will ask IdeaHouse to give me some set of inspiration. And here it first give me medieval night Lego minifigure, butler figures, and some diverse figures. And I see that the examples that IdeaHouse shows to you is actually diverse. This is correspond to what cognitive science have shown, that when you give people diverse example, it inspires them to generate diverse ideas, explore different creative paths. And this is not the only way that you can help people generating creative ideas. Sometimes when people find particular part of ideas that they think are interesting, for example, if I say, oh, I think medieval night Lego minifigures is actually pretty cool, I want to know what is more there. I asked IdeaHouse to provide me some similar ideas to the one that I'm interested in. And that actually, prior research in cognitive science has also shown that by seeing similar examples to something that you are interested in, it helps you, encourage you to explore deeply into that to generate creative variation. Apart from this type of inspiration selection that adapt to how people generate ideas, people might also benefit from just when they are confused about what is going on. Maybe it would be nice to have some sort of an overview that gives them a big picture of emerging ideas. So prior works has also shown that when people see a map of idea space or solution space, it gives them a big picture and help them derive insight. Like you can see cluster of ideas going on over here, some night cluster or some alien minifigure cluster. In IdeaHouse, we support these three types of interaction. We use semantic models that we call an idea map, which is basically a spatial low-dimensional space that put ideas on that space based on how they are related to each other. On this particular map, the ideas that are very similar will be placed close together, and the ideas that are very different will be placed far apart. So if we want to get an overview of the solution space, we can simply show people the idea map itself. And if you want to find diverse ideas, you can select ideas from different parts of the map. And if you want to look at particular similar ideas for ideas that you're interested in, you can just sample ideas that is in the vicinity of ideas of interest. Now, the question is, how do we make an idea map? We have to take into consideration that ideas are actually expressed in many forms. Sometimes we express them in terms of sketches, sometimes they are just short phrases or words. So we need some approach that can be generalized across different formats of ideas. And currently, the best way to do that is basically ask people how ideas are related to each other. And prior work have done this by using some semantic similarity microtask to generate the idea maps. Basically, it say that compared to this idea, alien general, which one is more similar, the astronaut minifigures or the butler minifigures. And it will collect a bunch of these responses to use them to generate idea maps. You'll see that usually it needs a lot of responses, and usually we outsource this to crowd workers. However, in this particular setting, there are some problem with just outsourcing these microtasks to the crowd worker as well. First is that you need to have some overhead set up the system. It costs money, and more importantly, when the ideas are confidential or some ideas are more complex, you cannot just give it to anyone. You cannot just outsource this task to crowdsourced workers. So how about asking the user who are actually already generating idea themselves to provide you semantic, to complete this semantic microtask? And some straightforward approach is, well, what you give to crowd workers, you just give it to your users, right? One thing is that this is an extra task on top of idea generation tasks that they are already doing, so it takes time from their main task, and sometimes they are repetitive, people might not want to do it, and it's not as glamorous as generating new cool ideas. So our challenge is that we have a task that people might not like to do, which is provide semantic information between ideas, which is kind of like eating broccoli. And we have a task that people like to do, which is generate new ideas. It's kind of like eating pizza, like we like pizza. And we need them to do them both. One obvious solution is, well, you can ask people to do both you can just stick pizza on the top of the broccoli. And we can see how that turned out.
Pizza sounds delicious.
Pizza?
Yes, pizza.
Right on, let's get it. What the heck is that?
It's broccoli on pizza. That's it. I'm done.
Congratulations, San Francisco. You've ruined pizza.
So when you put something that people don't like to do on top of something that they like to do, you might end up ruining what they like. In this case, you ruin the pizza. So, and we actually found this. We actually found this sort of reaction as well. So we conduct a pilot study. We ask people to generate ideas, and then we ask them to do this kind of semantic task on top of that. And people give us feedback that, oh, why are you torturing me? This thing is boring and cruel. So basically, just put things. Just ask people to do two types of tasks. Doesn't seem to work very well. And here we are looking more on more of the integrated solution where you actually mesh the task that people don't want to do with the task that they like to do in a way that they can barely notice that they are doing the task that they are not doing it. So to recap the task, what we talked about so far, we have a semantic models that help people do amazing things, or that help people find inspirations. And we say that microtask approach might not work in generating these semantic models. And our question is, how can we combine two types of activity neatly? In IdeaHound, we use an approach that we call integrated crowdsourcing. The idea of this is basically you seamlessly integrate the secondary task with the primary task in a way that benefit the user rather than harm them. And in our case, the primary task is generating awesome ideas, and the secondary task is provide semantic relationships between ideas. So how do we do that in the idea generation domain? We step back and take a look at how people come up with ideas. We notice that when people generate ideas in brainstorming session, they tend to arrange ideas spatially according to how ideas are related to each other. So we say, maybe we can make use of that activities that people are already doing So we conduct a pilot study. We ask people to generate ideas, and we provide them with a virtual whiteboard that we tell them that you can use this to organize ideas. And we found that people do naturally organize ideas. We didn't ask them to do that. We just say, here is a tool, you can use it or you cannot, but people do it naturally without being forced to. And they do organize ideas semantically. One surprising thing we found is that when we physical distance between ideas actually doesn't equate to semantic distance, because sometimes people organize idea like 20 ideas on the same whiteboard at the same time, and it's hard to keep track of all of them, hard to keep track of all physical distances. So instead, they just tend to group ideas into discrete clusters. And in our latest prototype, we provide people with an interface with a whiteboard that allow people to create cluster of ideas according to how they want, and they can also request ideas. So in this pane right here is the pane that they will see inspiration from others, and here is the pane that they can see their own ideas. And this is just basically the whiteboard that they use to organize ideas. So to walk you through a little bit, in this system, user can generate ideas, type the ideas that they like. Here the task is coming up with some movie titles. So here I would say Toy Story, and then you can look to see other people's ideas. IdeaHouse tried to select ideas that are diverse. And when people can also drag ideas to the whiteboard to organize, group them together, name the label of the group, so that when they come back, they can just jump right back into the cluster. And if they see ideas that they're interested in, they can ask to look for similar ideas. So for example, here the movie named Tarzan, the similar ideas are all ideas with the main character's name, like Finding Dory, Finding Nemo, and Mulan. So, and if the user want to get an overview of the idea space, they can also look into the idea map. Here they can see their own ideas in a separate color. And you can see that on these idea maps, the ideas that are similar are placed close together. For example, the ideas that are all adjective like tango and brave are grouped together, separate from something like Finding Dory. And the user can switch back and forth between these two modes. So here is what the user see. What is going on underneath is IdeaHound take how people cluster ideas on the whiteboard. So on the picture, this is an example right here. Each shape represents an ideas, and it would try to extract whether an ideas are being grouped together. It aggregates this information across different users and then use that to generate a similarity matrix. And the entry of similarity matrix is the probability that if two ideas are seen together, how likely it is that people will put them in the same clusters. And notice that this metric is sparse because not each pair of ideas will be seen together by everyone. So once we have this similarity matrix, we use an algorithm called t-SNE to generate an idea maps. What t-SNE does is take and input a similarity matrix and generate idea on low dimensional space. And you can see that here, the ideas that are similar, like the blue square over here, are being grouped together. So we have a system, IdeaHound, that extracts semantic relationships between ideas from people's activities, and we also have technical approach that use that information to generate an idea maps. Now the question is, does it even work? So here there are two questions that we need to answer. The first one is the question regarding the quality of the generated idea map themselves. Like, does the derived map, how much does it agree with how people perceive semantic similarity between items? And the second question is also about its impact of introduced interaction on user experience. If the user doesn't like it, then it's not helpful. And if the user performance is being affected by the introduced interaction, then it's not helpful either. In order to answer this question, we conduct an experiment. We ask Mechanical Turk workers to generate ideas to improve our microtask platform. We have two conditions in the experiment. In the first condition is the integrated condition, where we ask people to generate ideas into groups. There are 3 groups. And here we give them an interface similar to IdeaHound, where they can arrange, where they can cluster ideas on the whiteboard. And in the second condition, they have everything exactly almost the same as the other one, except that they cannot cluster ideas. So we run 2 analyses on this. The first one is on quality of idea map, and the second one is on user output and experience. For the quality of the ideas maps, we compare 2 idea maps against a standard baseline. And here, standard baseline is people's judgment of semantic similarities between ideas. And so we take one idea map from one of the integrated condition, and we ask another group of people to generate a different idea map, which we call outsourced idea map, by answering 1,000 triplet questions. And in the end, we look into the correlation of each maps with the standard baseline. For user output and experience, we look at quantity. For the output, we look at quantity, creativity, and diversity of generated ideas. And for the user experience, we look at mental effort and perceived helpfulness of the system. Here is an example of ideas map generated from the integrated approach. You can see that there are some cluster of ideas forming here. For example, here are ideas about payment. Here, there are some ideas about minimum wages or adapted wages based on the demand at the moment. And we look at the correlation of each map against the baseline. And here, the higher negative correlation is actually better, because correlation is correlation between distance between ideas and similarity judgment. And we found that integrated idea map actually correlate more with with the standard baseline. So the quality of the map that is being generated is actually pretty good. In terms of user experience, here is some example of how people organize ideas. Of course, some people will organize ideas just little. Some people will actually organize them extensively. We look into the output of the output that people produce, and they say there is no differences in quantity, creativity, and diversity of ideas. So basically, the extra interaction that we introduce actually doesn't harm the output of the users. And in terms of mental effort, in the integrated session where they have whiteboard to organize ideas, the mental effort is higher, but it tapers off in the end. And people find them to be similarly helpful, and some people in the organizing, people who can organize idea found that organizing idea actually helped with their main process as well. It helped avoid repetition, and it gives them a clear picture of how things work. So to summarize, we introduced a system called IdeaHound that helps a group of people generate ideas together. This system helps users explore ideas and find inspiring ideas from a large pool of ideas by using an idea map that creating from user natural activities while they are generating ideas themselves. And with that, thank you for your time and attention. I will take questions.
So if you have questions, just raise your hand and the SVs will bring a mic around to you. All right, so while we're getting questions, so do you get a sense of essentially where automation could play a role here? Is there some kind of automated, better automated clustering, or ways to find external resources or something like that that would be useful here?
I think definitely. So for example, it depends on the format of the text, but maybe you can automatically look up some sort of text, right? And you can just use some, because we just want to show that just purely human effort works, but you can imagine that this approach can be used to, you can integrate other automatic approach to extract similarity metrics as well. So yeah, the short answer is yes.
Do we have another question over there? And can we start setting up the next speaker as we answer?
Hey, great talk. Thanks. You started your talk with a really compelling metaphor about tasks that people did and didn't want to do. And I want to just draw out what exactly in this part, how did you transform the broccoli task into the more palatable task?
You mean like what is the formula of how to do this? Or?
No, I just guess from your experience, what was it that turned it around for people? It seemed like they felt maybe like cogs in the machine. And then in the second scenario, what was it that made them feel like this was different? Did they have more agency or more stake in the task or different incentives?
Yeah, I think the main incentive is because we also tell people that you might find this interaction that you do can be helpful for your ideation process, because like you can see that sometimes it gets confusing when you are generating ideas with a large group of people. And what they are doing is not only that it doesn't harm people, but it seems to be helpful for them in order to act as a jog of reminders of what they are thinking about as well. So, yeah, I'm not sure whether that answered your question.
Yeah, thank you very much.
Great. Do we have any other questions? We're trying to get some power to the stage right now. So, anybody else? Got a golden chance here. Okay, great. Let's thank Pal one more time.
Thank you.